Hello students, here the discussion on the different equations of motions are discussed over here. You please listen to it and try to understand. Okay, if there is any problem, please ask me. First, we will discuss about the first equation of motion, that is v equal to u plus at. Whereas v denotes the final velocity, u denotes the initial velocity, a is the acceleration of the body, and time is t for time is taken by the body. Okay, so here at first, according to this graph chart, we can easily say that OA, that is denoting as the u or the first or initial velocity. Okay, here bc is the final velocity, that is as equal as OE. So here we can say OE equal to BC is the final velocity of the body, whereas OA and DC are the initial velocity of the body. Okay, and OC is the time taken by the body. So here we can write in this way. Now we know that the body is moving, as if you observe this graph, you will observe that the body is not its primary position. It is not at the O position, it is at the A position. It means it has this body is moving, till now it is moving. So according to its time, if you observe the graph AB, you will observe that according to the time the body is moving. Okay, or it has the acceleration. So we can easily say that acceleration A equal to, we can take the previous formula that we have already taken through acceleration when we read it, that acceleration A equals to v minus u by t. Okay, v minus u by t. So first of all, we have already taken out the v minus u by t. How it has, we have to take that dc equal to bc minus bd. If you want to take out only the dc, then you have to subtract bd from bc. It means bc minus bd. Okay, then you have to interchange the places of those, then it will come as bd equal to bc minus dc, and we know that here bc is the final velocity, whereas dc is the initial velocity. It means bc means v minus dc means u, or bd equal to v minus u. That is the number 1. Now from here, when we are doing the acceleration, then we have to take out that acceleration A equal to v minus u by t, we everyone knows. So that's why no need to get hesitation that how can we do that. Now from here you have to interchange by the simple equation process, and through there easily you can take out v equal to u plus at. Okay, so this is the first equation of motion. Now we discuss the second equation of motion. It means our second equation is s equal to ut plus half at square, whereas s is denoted as the displacement of the body, whereas u and t the initial velocity and the time is taken by the body, plus half at square means the acceleration and the time is taken. Okay, so from this we can easily understand through the graph that O is the OA or DC is the initial velocity, whereas BC is the final velocity, and AB is the moving of the body according to its acceleration and uniformly according to the time, that is entirely known as the displacement. So to find out the displacement, first of all we have to take out the entire area of OABC trapezium. OABC, through its graph easily you can understand that it's a trapezium through which we can take out the area of it. How can we take it out? We can easily divide it into two parts, that is OADC is a rectangle, whereas ABD is a triangle. So the area of OADC rectangle we have to find out, plus triangle ABD, the area also have to find out, then we have to go for the addition of it. So if we go for the addition, so it will come as s equal to ut plus half into t into v minus u as the equation number 1. Okay, and again we will take the first equation that we got in our first equation of motion, that is v equal to u plus at. From here we have to take out v minus u equal to at, and we have to take out as a second equation. So from 2 and from 1 equation we can merge it. If we merge it, so we can easily get s equal to ut plus half into at into t, And where here you will observe that v minus u has already changed as at. Why? Because from equation number 1 or first equation we have already taken it as v minus u equal to at, so that at has put over there, and our final equation of the second motion, that second equation of motion, it is s equal to ut plus half it square, it proved. Here in third equation of the motion, that is v square minus c square equal to 2aa, so to find out, and I haven't written so long because the primary part is the same as the its first equation and the second equation. So here accordingly to that we have to make the graph again, and from here we have to take out the entire area of OABC for the third equation of motion, and here we will not divide this trapezium into rectangle and a triangle just like the second equation. Here we have to put the trapeziums its own rule, it means its own formula of the area, and that is, we know that half into b1 plus b2 into height. Okay, it means half into base 1 plus base 2 into height. Now here according to this graph, the base 1 is OA, it means the primary velocity or the initial velocity, whereas b2 means the final velocity or the BC, and the height is OC, means the T. So according to it we can just write it down, half into u plus v into T. So it is our first equation. Now from the second, first equation we get that v equal to u plus at, and from where we have to take out the value of t, that is v minus u by a. Okay, so it is the second value or the second equation. Now from this first and second equation easily we can get s equal to half into u plus v into, instead of t we will write v minus u by a. Okay, now we will just do the simple equation, and through it we can get easily 2a is equal to v square minus u square, and it is proved.